In today's session, we are going to discuss about OR gate and 7432 IC. Also, at the end of this video, we will see implementation of OR gate using Tinkercad. So let's start. What is OR gate? OR gate is one of the basic gate. What OR gate does? OR gate takes multiple binary input and produces an output that is high if at least one input is high. What is the meaning of this? So it indicates that the output of OR gate will be logic 1 if at least one input is at logic 1. कम से कम एक input क्या होना चाहिए? Logic 1 होना चाहिए. So let's try to understand this with the help of truth table. So this is truth table of 2 input OR gate. So here you can observe that A and B are the inputs and Y is output of the OR gate. So let's try to understand first row of the truth table. So in this first row, A and B both are 0. So if both inputs are 0, then of course output of OR gate will be 0. Then consider second row. In second row, A is 0, B is 1. B is at logic 1. So what is condition in OR gate? At least one input it should be at logic 1. Then output of OR gate will be logic 1. So here B is at logic 1. So that's why you can observe that output of OR gate will be 1. Similarly, in third row also you can observe that one of the input, at least one of the input is at logic 1. And which is that input? A. A is at logic 1. So that's why output of OR gate will be 1. In last row, what is happening? Both inputs are at logic 1. So if both inputs are at logic 1, then what is going to happen? Of course, output of OR gate will be logic 1. Okay, because a condition in the OR gate is कम से कम क्या होना चाहिए? कम से कम एक input logic 1 होना चाहिए. यहाँ पे both input logic 1 है, no issue. So output of OR gate is going to become logic 1. I hope the truth table of OR gate is clear to you. Now let's discuss 7432 IC. So what is 7432 IC? 7432 IC is OR gate IC. So this IC contains multiple OR gate. So how many OR gates are present in 7432 IC? So observe this diagram. So in this diagram you can see that 7432 IC contains total 4 OR gate. Then how many pins are present in 7432 IC? 7432 IC contain total 14 pins. Out of this 14 pins, 7 pins are present on one side of the IC and remaining 7 pins are present on opposite side of the IC. So let's try to understand now this pin diagram. So pin number 1 and pin number 2. Pin number 1 and pin number 2, they will act as input for the first OR gate, and pin number 3 will be the output of first OR gate. Then pin number 4 and pin number 5. Pin number 4 and pin number 5 will act as input for second OR gate, while pin number 6 will act as output of this particular OR gate. Then pin number 7 has to be connected to the ground. Then come to the opposite side of the IC. So pin number 9 and pin number 10, please try to understand, don't get confused here. Pin number 9 and pin number 10 will act as input for third OR gate, and pin number 8 will act as output of this third OR gate. Similarly, pin number 13 and pin number 12 will act as input for the fourth OR gate, and pin number 11 will act as output of this particular OR gate, while pin number 14 will act as VCC. It has to be connected to the VCC. So this is about pin diagram of 7432 IC. Let's see implementation of OR gate using Tinkercad. So first of all, I will open Tinkercad website. So already I have logged into this particular website. So that's why I am able to see interface like this. Then here you will get one option called as design. So just you need to click on this design. Then here you will get one option called as create. So just you need to again click on this create circuit. So I want to create new circuit. So that's why I click on this option, create circuit. Then you will be redirected to this particular web page. In this web page here you can see one search box. So here first of all I will type breadboard. So I will take one breadboard here. Okay, so just you need to perform drag and drop operation. Then here I will take battery. So I will take 1.5 volt battery. So I will take such 3 batteries and I will connect them in series so that approximately I will get 4.5 voltage. So I will connect positive terminal of first battery to the negative terminal of second battery. Similarly, I will connect positive terminal of second battery to the negative terminal of third battery. I will connect negative terminal of first battery to the negative rail of breadboard. Then I will connect positive terminal of this last battery to the positive rail of the breadboard. Then I will connect first rail of the breadboard to the second last rail. I will connect second rail of the breadboard to the last rail of the breadboard. Then here I will take one IC. Name of that IC is 7432. So just you need to perform drag and drop operation. So see how I have arranged 7432 IC on the breadboard. So this IC, it has got 14 pin. So how to identify pin number 1? So on this IC you can see one dot. So the pin which is near to this dot will act as pin number 1. So pin number 1, 2, 3, 4, 5, 6, 7. Then on opposite side here you will find pin number 8. 8, 9, 10, 11, 12, 13 and 14. Now let's connect pin number 7 to the ground. So we have already seen pin diagram of 7432. So pin number 7, it has to be connected to the ground. So I will take connection from this pin number 7 and I will connect it to the ground. Then I will connect pin number 14 to the VCC. So this is pin number 14. Pin number 14. So I will take connection from pin number 14. I will connect it to the VCC. So let's change its color to suppose red. Then here I will take 2 slide switch. So this 2 slide switch, they will act as an input for my OR gate. So this is first slide switch and this is second slide switch. So if you observe this slide switch, you will come to know that there are 3 pins which are present in this slide switch. So this terminal 1, I will connect terminal 1 to ground. I will connect terminal 1 to ground. So let's again change its color to green. Similarly, I will connect terminal 1 of this second slide switch to the ground. Then I will connect terminal 2 of first slide switch to the VCC. So again I will change its color to red. Similarly, I will connect terminal 2 of second slide switch to the VCC. Then this slide switch, it has got common terminal. So this common terminal will actually act as an input. So I will take connection from this common terminal and I will connect it to pin number 1 of 7432, which is nothing but input of first OR gate. Similarly, I will connect common terminal of the second slide switch to the second pin of 7432, which is second input of first OR gate. Then pin number 3, we know it will act as an output. So for output, I will take one LED here. Then here I will also require one register. So I will take one register here. Just press R key present on the keyboard. Okay, so by using R key we can rotate this particular register. So I will connect one terminal of the register to the cathode and other terminal of this register, it has to be connected to negative rail. It has to be connected to negative rail of the breadboard. Then I will take connection from pin number 3, which is nothing but our output, final output. So I will connect this pin number 3 to the anode terminal of the LED. That's it. We have completed connections. Now let's start the simulation. So I have started the simulation. Now this slide switch, in this slide switch you can see one white strip. So currently this strip is on left hand side. So on left hand side we have terminal 1 which is connected to ground. So that's why I can say that current state of this slide switch is 0. Similarly, current state of this second slide switch is also 0. So both inputs are 0, 0. So that's why the output of OR gate is 0. Now I will change first input. I will make first input 1. How? So you need to click on this particular slide switch. Okay, so now you can observe that this strip has moved on right hand side. So on right hand side we have got second terminal which is connected to VCC. So that's why I can say that current state of this particular slide switch is 1. So the inputs to our OR gate are 1 0. So inputs to our OR gate are 1 0. So that's why you can see that this LED is in on state. When both inputs are 0 0, see, observe that it is output is 0. So LED is off. Whenever I will make first input 1, so output of OR gate will be 1, and that's why LED will be in on state. Similarly, you can verify that whenever the second input is 1, then also LED will be 1. Whenever both inputs are 1 1, then also LED will be in on state, means output of OR gate will be 1. So in this way, we have verified truth table of OR gate with the help of Tinkercad. Thank you for watching the video.